The sun changed rhythm before the spot appeared. NASA's model caught that warning up to 12 hours early. Look at the target square. At first, no sunspot is visible, but beneath the surface, the acoustic signal drops while the magnetic signal rises. By the end, you will know what those 12 hours can and cannot buy us. What appears first? A sunspot is only the visible face of an active region, a knot of magnetic energy pushing through the solar surface. These regions can release flares and coronal mass ejections. If one is aimed our way, astronauts, satellites, radio links, navigation, and even power systems may feel the consequences. Today, forecasters watch regions that have already appeared. The COFFIES research team asked a harder question. Can we detect one while it is still hidden? Why listen for sound? The sun is not silent inside. Hot plasma churns and acoustic waves travel through it. A rising magnetic structure changes how those waves move before the structure breaks through the surface. It also leaves small magnetic changes above it. NASA's Solar Dynamics Observatory measures both signals. In this real example, active region 158, the darkening acoustic map and strengthening magnetic map begin to separate from the background before the spot fully emerges. How does the model read it? The team trained a sliding window transformer. Imagine moving a short frame across a long timeline. The model concentrates on the newest measurements while remembering patterns that appeared earlier. It then estimates where an active region is likely to emerge. Not the exact size of a future flare, and not whether a storm will hit Earth. That distinction matters. This is an active region early warning, not a guaranteed solar storm forecast. Researchers reported approximate locations up to 12 hours before visible emergence. But the system still needs testing on more events before it can become an operational tool. If you controlled those 12 hours, what would you protect first? An astronaut, a satellite, an airline route, or the grid? What could 12 hours change? For a spacecraft team, it could mean checking a radiation plan before a region becomes obvious. For a satellite operator, it could mean preparing for charging or communication risk. For forecasters, it could add an earlier clue to models that now begin with what is already visible. 12 hours cannot move Earth out of the way, but in systems where procedures, instruments, and people need time, an earlier signal can turn surprise into preparation. What cannot this claim? Not every active region erupts. Not every eruption points at Earth. The model does not yet tell us the exact flare, arrival time, or damage. Its strongest result is narrower and more useful because it is testable. Subtle acoustic and magnetic changes can reveal where a hidden region may appear. The proof object is still that square. First, a change in rhythm, then a visible active region. If the sun whispers before it shouts, the next frontier of space weather safety may begin by listening early.